Okay, 6-9 is the last section in Chapter 6, which means a test coming soon. But this section's a little bit special in that it's just a big review of all the differentiating and integrating. And what I'm going to do for the next 4 days is break you into groups of 3 or 4 and have these problems be group quizzes. So that's the plan. But there's a couple little rules we need to get out of the way. We're going to discover 2 rules today. We've been doing this the long way. Now we're going to come up with a little rule that we can put on our blue sheet. Discover the derivative of b to the x. Some number raised to the x power, like 2 to the x, 5 to the x, 10 to the x. Okay, let's go through this where b is a number, so we're going to let y equal b to the x. Remember, b is a number. So in order for us to do derivative, we had to get the x down, so we had to hit it with the log on both sides. Oops, b. I brought the x down as a multiplier already. Now we're ready for derivative. Derivative here is 1 over y prime. Remember, this is a number. Derivative of x is 1 times this number is natural log of b. And then we multiply by y. And y was b to the x. So, on your blue sheet, we're going to put this derivative. I'm not sure where we want it. I'm going to stick it in here, wherever you have room. The derivative with respect to u of b to the x, or I should say b to the u, is b to the u is itself times the natural log of b. There it is. So the derivative of b to the u is itself times the natural log of the b. That's going to happen every single time because it's the original equation that gets multiplied in, and when that comes down, that derivative goes to 1, we just get the natural log of that number that was there. So I had y equals 8 to the x. Hopefully you don't have to go through the long way here. You can just know, oh yeah, I've got this rule on my blue sheet. Y prime will equal 8 to the x times the natural log of 8. Okay, now we want to discover the integral of b to the x dx. Okay, I gotta find it. Okay, this one's a little bit trickier to discover. Alright, so if I start with a number, it's going to be easier with a number here. The integral of 5 to the x dx. Our goal is to get this in the form of e to the u du. Because I know e to the u integrates back to itself. So what I'm going to do is rewrite this, the 5 part of this, just the whole number 5. 5 can be rewritten as e to the ln of 5. Because remember, when you have that e raised to the ln, they just cancel out and you're left with this. So I'm going to replace the 5 with this e version of 5. So what I'll have is e to the ln of 5 times by x. I'm going to go this way. Okay, so if I let u equal this whole exponent here, u equal the x and the ln of 5. The u prime then equals ln of 5. Forgot my dx. So that means I need an ln of 5 attached to the dx. Ln of 5. So that means I need a 1 over ln of 5 here. And so then it's e to the u prime. It integrates right back to itself, and then I just got to carry this along. So I'm going to have e to the ln of 5 times by x all over ln of 5. Because of the 1 over ln of 5 here is going down here. I'm going to bring this back up as an exponent. E to the ln of 5 to the x over ln of 5. If I do a little simplifying, brought that x up. Now I'm going to simplify. The e and the ln are going to go away. I get 5 to the x over ln of 5 plus c. So, what does it appear the rule is going to be for the integral of b to the x dx when I had 5 to the x dx and it came out 5 to the x over ln of 5? Well, it certainly looks like it's going to be itself, b to the x, divided by the natural log of that number, b. And it is. So, on our blue sheet, down here in the integration rules, the integral of b to the x dx is itself divided by the natural log of b plus c. Okay, so if I want to run a quick example here, the integral of 8 to the x dx fits that form. I know it's going to be itself divided by natural log of 8 plus c. Okay, the last bit of rules are the other trig functions. Because we've done sine and cosine, we know what those integrals are, and derivative. So the other 4 rules for integrating cosecant, secant, tangent, and cotangent are coming at you, and we're going to stick those right on the blue sheet. So, the other trig functions. Let's go here. Well, I guess I could do all 6 of them. So the integral of sine u du, as long as I have the u prime here. And we did this one. We didn't even have a rule for it, but we've always done it. What has sine as its derivative? Negative cosine plus c. The integral of cosine u du, as long as the u prime is attached here, sine has that derivative. Now the ones you don't know. Let's see. Need a little bit more room for these. Slide back over. Cosecant u du with the u prime is negative natural log of the absolute value of cosecant u plus cotangent u plus c. And it has a second version. Could be the natural log of the absolute value of cosecant u minus cotangent u plus c. So the negative out in front of the log, or a subtraction in between, one or the other. Secant u du with the u prime here is the natural log of the absolute value of secant plus tangent. Tangent. Oh, where am I? Ooh, good thing I looked. Tangent. Tangent, we've got two versions again. Negative natural log of cosine u plus c, or natural log of secant u plus c. And the last one, God, it got kind of ugly in here. The integral, I think this is the end of it for the blue sheet for the year anyway. Cotangent u du with a u prime is natural log of absolute value of sine u, or negative natural log of cosecant u plus c. Okay, sorry that got so smushed in there. But that's I think that is the end of the blue sheet. Okay, you got 4 days of group quizzes coming at you. No homework on this.